Hi, I'm Roland Minton. These are some of my favorite math stories. In this episode, Mathematics is Numbers. We'll look at the math-based television series Numbers, which ran from 2005 to 2010. Many of its episodes were based on real uses of mathematics in crime solving, and the visual explanations of the mathematical thinking were often excellent. Much of the information in this episode comes from the book, The Numbers Behind Numbers. The show follows the exploits of two brothers, one an FBI agent and the other a brilliant mathematician. The contrast between their outlooks on life and their personal strengths and weaknesses are well done. With attention paid to their mathematical consultants, the writers stayed reasonably close to mathematical reality while making a good case that math is everywhere. In the pilot episode, Charlie, the mathematician, creates an algorithm that uses the locations of attacks by a serial killer to predict where the killer lives. The result, like many in the show, is presented as a heat map showing areas that are more or less likely to be correct. I appreciate that they don't completely overplay the accuracy of the algorithm. The algorithm in real life was developed by Kim Rossimo and is a remarkably effective and simple calculation. The insight in real life, as in the show, comes from a sprinkler. If you know where water droplets from a sprinkler land, you can go back and figure out where the sprinkler is located. The theory on serial killers is that they have two main criteria. Don't strike too close to home, but don't strike too far away either. For a given point, Rossimo's formula is a sum of distances to crime locations plus the distances to a hypothetical buffer zone, for example, a circle 1 mile from the point. A heat map of the sum gives information about the killer's home or work site. Having a narrowed search area allows the FBI to catch the killer. In a Season 3 episode named Hardball, the plot centers on a baseball player who dies of an overdose of steroids. An early suspect is an enthusiastic fantasy baseball player and self-taught mathematician who had developed an algorithm to identify steroid use in players. Charlie is amazed to discover that the young man had reinvented a well-known result from change point detection theory. We'll look at perhaps the most efficient detection system. Developed by E.S. Page, the Page system is designed to detect a change from state A to state B. Let's see if we can detect Barry Bonds' use of steroids using his home run rate as an indicator of power. In 1991, Bonds hit 25 home runs and 510 at-bats, a rate of .05 home runs per at-bat. In 2001, he hit 73 home runs and 476 at-bats, a rate of .15 home runs per at-bat. To use the Page system, we use the ratios .15 over .05, which is 3, and 1 minus .15 over 1 minus .05, .85 over .95, about .9. Start with the Page index of 1, p equals 1, and look at Bonds' at-bats one by one. If he hits a home run, multiply p by 3. If he doesn't hit a home run, multiply by .9. If this reduces p to less than 1, start over. Reset p to 1. If p exceeds 75, stop and declare that his home run rate has changed from .05 to .15. I ran 1,000 simulations, first assuming that Bond's true rate was .15. On average, it took 46 at-bats for p to exceed 75. In 11 to 12 games, on average, the Page system announced a change in the home run rate. Does this prove steroid usage? Well, no, but it does set off an alarm that something is going on. There's a very important second calculation to do here. Assuming no change, a true home run rate of .05, does Page system set off false alarms? And on average, it took 1,411 at-bats for a false alarm, about 3 years' worth of at-bats for Bonds. Looking at the yearly home run rates in the graph, it's clear that Bonds' home run rate did not immediately jump from .05 to .15 and stay there. In fact, the increase in his first 12 years is not unusual for a maturing hitter. But then there was another jump. His 1998 home run rate was 37 over 552, .067. His 1999 home run rate jumped to 34 out of 355, .096. Repeating the Page system with new ratios .096 over .067, 1.43, and .904 over .933, 0.969, I ran 1,000 new simulations. Assuming the larger rate, it took an average of 486 at-bats to detect a change. So by the end of the season, there was statistical evidence of a real change in 1999. What about the false positives? Well, on average, it took 9,345 at-bats, 8 to 10 seasons, for a false alarm. A typical player would be starting to decline in his mid-30s. Instead, Bonds took another statistically significant jump up and maintained or improved upon it through age 40. These experiments illustrate that the page system works pretty well. Let's do one more episode of Numbers, titled Protest from Season 2. After a bombing which has characteristics that mimic a protest bombing from 35 years earlier, Charlie analyzes an old social network of activists. Graph theory has been used by, as the book Numbers reads, the National Security Agency, known to be the largest employer of research-level mathematicians in the world, and affiliated organizations such as the Centers for Communications Research, to help understand the organizational structure of criminal groups. In the graph, you can see that there are 3 or 4 hubs of communication, and graph theory provides computational tools for identifying hubs in the absence of nicely drawn graphs. One measure of centrality for a node, a person, is called the degree score. That equals the average number of links coming from that node. A hub would typically have a large degree, and a peripheral contact might have only one link. There's also the betweenness score. This is a little more complicated and depends on the proportion of times that the node is a part of the shortest path between 2 other nodes. For 2 peripheral nodes to communicate, they need to go through a central node. Finally, there is the closeness score, which equals the average number of links it takes to get to the other nodes on the graph. See the episode 6 Degrees. The numbers behind Numbers shows that all 3 measures identified a ringleader of the attacks on 9/11. Charlie's analysis of the old activist network, of course, is central to solving the bombing. Yes, mathematics does not always correctly identify human behaviors, but it's great that there was a TV show building enjoyable episodes around real mathematics. Other episodes have The Prisoner's Dilemma, 6 Degrees of Separation, card counting, and many other topics covered on this channel. Check out Numbers.